Hi and welcome back to Programming with R and Matlab. My name is Ian and I'm Finance Teaching Assistant at Stockholm Business School. So today we're doing the final touches on our algorithm. It is the last video in our course Coding in R, and we're going to take a look at our last fifth logical block, which makes our algorithm more usable and more user-friendly. So we're going to take a look at the top 10 stocks which we have included in the portfolio, and we'd like to show them. So we need to show the cumulative returns during the whole period so that we can evaluate how good our strategy is. We're also going to compare these cumulative returns with OMX30 to see if we were good comparing to the market or not. And we're also going to show which stocks you have to include in your portfolio today. And let's first of all think over how we're going to calculate cumulative returns. We're going to calculate it with daily log returns. Why? Because it is much easier to use log returns. To calculate cumulative returns, you're just going to add all log returns and you will get representative cumulative returns. And we would like to calculate log returns for each day, so it means that we're going to use a loop again. But let's think over a little bit how we can do it. So we're doing it with this algorithm. We're going to, for each day, we're going to calculate portfolio log returns using the formula. But at the same time, let's also try to visualize it. So let's say this is going to be the timeline of a stock price. So at specific point, so each of this point here, this and this one, is going to be some point of time, and each of these points it's the price of the stock at a specific point of time. Let's say we're now standing here. There is no signal for us to include this stock. This is why we don't have anything to do. But then we're traveling time, and it gives us a signal that you have to buy at a closing price. So pretty much what we're doing, we're creating a portfolio in which we're including this stock. But we do not have any return at this day because we just bought the stock. Then we travel in time, and let's say next day, our algorithm says that this stock doesn't have any buy signal anymore, so we're not including it into our portfolio. In this sense, we're also creating a portfolio once again, because we're getting rid of some stocks and maybe buying some new one. But at the same time, the return we're going to have here is going to be the return of the portfolio we created in the previous time period. We're going to use it when we're going to do the calculation of the cumulative returns and the portfolio returns. So let's go to R. Here it is. We stopped at the place where we included our portfolio, where we pretty much formed the portfolio. We know which stocks are in our portfolio. We just need to calculate the returns. We need to calculate it for each date time point. So we're going to still use this general loop for efficiency, but we are going to create a separate variable which will store the returns of the portfolio. Returns of the portfolio. And we call it port_ret, like portfolio returns. And it's going to be a vector which will store numeric data, and we would like to have a returns for each time point. But how many columns are we going to have? One, because we're going to have only one return of the portfolio for each day, for each time period. So we're going to type number of time. As you recall from our basics video, we're using equally weighted portfolio. So it means that the return of the portfolio at a specific point of time is just an average of the returns of the stock which consist in this portfolio, which pretty much is this portfolio. Then we would like to know how many stocks we're going to have. We know that we're going to have not more than 10, but it can be 2, it can be even 0. So we're going to write, to create a new variable, number of portfolio stock, import stock, where we're going to set it 0 at the very beginning, and this will just show us how many stocks we have at each period of time. So this will be changing dynamically as time changes. Great. So let's take a look here. We are including the stocks. So this one where we're creating a new portfolio. Now we need to calculate the returns of the previous portfolio. So of the previous time period portfolio. So we're going to use ID time -1, like stepping back. Okay, and at the same time, we know that if we hold the stock, this field will have. Oh, let's take a look maybe here. Can we take a look at the yes portfolio? Good. So it's loading. Yeah, let's just stick here. So if we do not hold the stock, we will have 0 in each cell of this, or at any. Start new session. Okay. Well, something went wrong, obviously, and I think we need to recalculate and change the working directory once again. Well, this happens from time to time. I will get back when I settled everything up to its initial state. Hi and welcome back. Yeah, after there was some crash which was associated, I believe, with our portfolio matrix. I don't know what really happened, but well, when you have this, you just need to reload all the things, and if you have this thing, usually it's much better to have your data stored somehow, the whole thing, so that you do not need to recalculate it. And to do this, you can save this environment by pressing here, and it's our project, it's our working folder, and you just type the name that we call stock data, and then you will have this R data thing, so that you can quickly import it back. Okay, where did we stop? Oh, we specified the number of portfolio stocks, and we were speaking how to identify how many, like if you had stock in your portfolio or not. So if you come back here, yeah, 0, it means that it doesn't have anything, so there is no stocks to invest in. And if there is a number, it means that it found some stocks you should invest, and this is their ID. So obviously, if the cell is more than 0, then you have a stock to invest, and we're going to use this restriction to find how many stocks we need to invest in. So portfolio, and we're referring it at a previous time, so it's ID time -1, and we're referring to ID, and ID is going to change from 1 to 10, so from referring to each column in here up to the 10th. We're going to check if it is more than 0. If it is more, then we have a stock, and we would like to include log return of this stock. And for this, we created a special function port return, port ret, or not function, a variable portfolio return with port, which is going to store our values, and this is specific for the ID time, at a special point of time. We're going to calculate log return of this stock, and we're going to divide. so we need to stock data. We need to find the stock in our general database portfolio. ID time -1 ID. So what we're doing here, we're saying look in the general database of stock data and find such a stock which has ID number equal to the one which is stored in our general portfolio list at the previous time period and has a position, and by position I mean the column number, which is equal to ID, and ID is going to change from 1 to 10. And then divide it. Excuse me. Yeah, we found the stock. We need to find the price. Prices. Is it prices? Wait. Was it prices? Did we use prices or price? Prices. With S. Yeah. Okay, prices. And we would like to write inside here ID time, so that it is at now, so we're selling it right now and we're buying new stocks right now. So we're thinking we're doing it simultaneously. And then okay, it should be inside log, dividing, just copying the whole thing because we're referring to the same stock, but instead of here I did time -1. So this is the price we bought our stock for, and this is the price we're selling it for. Bam. Also, we would like to use it kind of as a cumulative thing. So right now if you run the code, it will only store the log return of the latest stock. But we would like it to accumulate. So what we actually need to do, we need to add here port ret at ID time. ID time. So what does it actually mean I'm doing here? Some of you may think that, well, how it can be possible that one variable is equal to the same variable. So the thing is that when we created the portrait here, the vector, let's create it actually pretty fast. So you see each element of this vector is going to be equal to 0. So the initial value of the variable is 0. But then if you're going to use the same variable, kind of add a number to the variable and assign the value to the same variable, it will just firstly do calculations, then get the result, and then only override the initial state. So to get the idea what I'm talking about, let's say like this: a is equal to 2, yes? Then we would like to assign a is equal a plus 1, and now we would like to see a is going to be equal to 3. Why it is that? Well, it's not actually a mathematics which we're using, because some of you may think, okay, but if it is, let's say, a equal a plus 1, then a and a is going to be self-cancelled and 0 is equal 1, which is completely not nonsense. Computer sees it in the different way. Okay, I have a variable a, and I want you into this variable a assign a value a plus 1. So computer will firstly calculate this thing, and it will take 1 and plus whatever is stored in variable a. So it will pretty much search its memory to find the variable a and find that it has a value of 2, and instead of putting a, it will put 2 and then 2 plus 1, and then it store the new result in variable a. Whew. So pretty much if you want to do counters, this thing works really good. And we're going to do some kind of counter here. So we're going to write num port stock is equal num port stock plus 1 as well. And why it will work, we assign the value 0 here. So at each time period, at each time period, this value will be increased by 1. The problem is that and why we need it so that we can just then divide it, like port red at special ID time is going to be equal to port red at special time period just divided by number of portfolio stock. But then when we are going to run this whole loop, this portfolio stock will increase, I don't want to say indefinitely, but it will just be increasing. So we need, so pretty much the next time interaction, it will not read this line. It will go in here, read the whole code, find the new port stock, which is going to be increased by whatever number of stocks we initially include at the time period, 50. So let's say we're now at 51. And then we'll start adding 1 to each. We don't want this. We want to know how many stocks we hold at each specific point of time, so that each time it will start this script, we have to be sure that that the total number of portfolio of stocks is equal to 0. We can write it here before the loop, or we can actually set it equal to 0 just after we used it. And this is actually much better, because then you can always check that you didn't forget it. Like, I usually try to put these counters or something like that at the end, at the very end of the code, when I'm definitely not going to use the number of portfolio of stocks. Oh yeah, not going to use this variable, I mean. Also, we would like to think over the situation when we are not having any stocks at all. Then it will show us 0, and then this line will give us an error. Why? Because you cannot divide by 0. So what you're going to do, you would like to check if the number of portfolio of stocks is actually 0. If it is, then we don't need to do anything, we don't need to divide. But if it is more than 0, we would like to divide it like that. Some of you may say, but why can't we just do it 1? Because then it will because if it's 1, it would be the same portfolio return. Yes, you absolutely can put even 1 here. Why I put 0? Well, just because it will work with 0 as well. And 1 will also work here as well. Why? Because the number divided by 1 is going to be the same number. So, well, it doesn't really matter for this purpose. And after we run the whole code, it will give us, in the portfolio portrait, it will store all the portfolio returns, daily returns, over the whole period of our investments, or when we were testing the strategy. Let's save the code. Then what we would like to know, so you see, now we finished our big general loop, and all the things we're going to do lately, we're going just to use to calculate cumulative returns, and cumulative returns do not needed to be calculated for each data point. At least they're not needed to be calculated in this loop. To calculate cumulative returns, let's calculate cumulative returns. To calculate portfolio cumulative returns, we'll call it port cum, and we're going to use a special function which is called cumSum. What it does, it calculates the cumulative sum, and what we just put in, we need to put in vector, and that's it. And the cumulative returns of our portfolio are calculated if we're going to run this whole thing. Then we need also to calculate, so let's take a look back. So show cumulative returns, well, we also need to compare it with OMX 30. So we need to calculate the cumulative returns of the OMX 30 index. To do this, we need to calculate log index log returns index log, or I think it's caps lock, yeah. Index log is going to be equal diff log and stock data 1, because 1 it's our index, and then prices, and we would like to divide to oh, actually no, that's it, that is it, stock data prices, and then it will take the difference of each, and okay, this we don't. And then we would like to find index cumulative, and we're going to use consum again for index log. Good. Afterwards, we want to plot both of them. One of the best way to plot multiple data is actually to form a matrix, which you will call plot matrix, and you're going to use the function matrix, and then you need to assign data. It's going to be the first thing in here, and to use it you can pretty much write it like this: data is equal, then you would like to combine these two vectors into kind of one. For this you need to use letter C and then open the brackets, and then you just write portcom, for example, and then index. Good. And this shall do the whole thing. Oh, it's not data, it's data. Also, you would like to specify how many number of columns you're going to have, 2, and how many rows you would like to have. So an row is going to be equal length. Length is used only for vectors, and these are our vectors. We would like to use it on port. Oh. Good. And we're done with this. And afterwards we created the matrix. We would like to use a special function matplot, and we're going to specify our plot matrix as our x, or as our y, but just specify plot matrix in here. Then you see type. We would like it to be printed in lines, so this is why type we write L here, so it will be printed in lines. Also, you see xlab, ylab, it shows you x label and y label. Then you would like to specify which colors you would like to use, so 1 to 2 because we have 2 data, and you would like also to say pch equal to 1. So pretty much this will allow us to print this data in different colors. Also, you would like to add xlab maybe equal, then you need to specify, so xlab is going to be time, ylab is return, but not in percents. What else can we, pretty much that's it. Also, we may even specify the legend, and for this we just type legend in here. And first we need to specify where we want to put our legend. Let's say in bottom left corner. Then we need to specify how we will call our data. So first one, we have a portfolio return, so it's going to be portfolio, and the second one is index. Oh, good. Also, we would like to select pch1 and color equal 1 to 2. Okay, so let's take a look what we have. We have written the code for this too. maybe we can actually try before continuing showing the stock, so we may just try to see how it will work out. Let's just run these two lines and create the variables if needed. We just going to select everything and let's run. Okay. Good news, index is plotted in a good way, portfolio is not plotted at all. What's wrong? Something went wrong. Okay, arrow object num stock. Num port stock. But we have our num. Where do we have it? Num stock, and we have num stocks. Well, no, we have num stock. Something is wrong here. Okay, let's run this thing once again and run the whole thing. Okay, so you see everything worked pretty well. We have something that went really bad with index over here. Well, but I think it's okay. I don't remember that the index actually fall that much. Let's take a look at our data. It was okay. Stock data 1. We can actually take a look at the prices, and let's select 10 last observations length. So we need to say length stock data. This thing I'm showing you, it's really good for debugging, or when you have when you don't really know or how many observations we have. Actually, we don't even need to specify this thing. Excuse me. We just need to use num time. Num time minus 10 till num time. Yeah, the last observation doesn't look that there should be this type of fall down. Why did it calculate it like that? Okay, I will take a look at it and I will get back when I will figure it out why what went wrong in this particular graph. Okay, welcome back. I figured out what was the problem. So remember when we were calculating the log returns, we're getting rid of one observation. Well, when we were calculating our portfolio returns, we created it so it's to be equal length to the total number of times, so that then each time period is pretty much the same. It does not apply though to our log returns index, or to our index returns, because here we actually lost one observation. And when you try to plot it, it will come to the last observation, which is going to be shifted in next observation, and then the lost one in here, it will be treated as NA. So this is why we have this drop down. How to solve it? Well, you go back to your matrix where you were calculating the portfolio returns, and then instead of writing portcom, we're going to write indexcom here, and we're going to specify that we would like to have it only from the second element till the end of length portcom. And now if we will run this code, yes, you see it's solved. So pretty much what it did, it shifted the whole line over here to the right. And it's okay because we didn't have the data to the num time. So because we lost one observation here and we didn't correct it for this in here before, we had this issue. Okay, so let's take a look what we... Okay, what we have to do now, we have to show which stocks you have to include to your portfolio today. Okay, so we would like to so let's say showing stocks to include. But before, let's think over, is it enough just to show in the graph to see if our strategy works or not? Well, in this particular case, yeah, it's pretty enough, but let's say that it would be pretty close, and we don't really know which one is better. Just invest everything into ETF or follow our own strategy maybe. Then we may need to have some additional statistics. So let's say printing statistics, and for this we would like to create again matrix, and we will call it performance summary. And this is going to be matrix which will have data is equal to C, and then we are going just to mention all the elements of this matrix. So pretty much you just mentioning all the elements as they are, and just in line as it does in here, for example. And then by specifying number of columns and number of rows, you are shaping the whole data. So for example, if you just write it in this whole line and then say that you have only 2 columns, R will automatically say these 2 elements: first line, second line, third line, and so on. We would like to include the mean of the returns, so we need to know what is the expected daily return of our strategy as well as the portfolio. So let's say port return here, then so it's mean. Next we would like to also say mean for index log. Then we would like to calculate standard deviation of our portfolio return. And also standard deviation of our index returns, index log. In addition, we actually would like to know the precise and value of our cumulative return of our strategy and of the index. So pretty much this, we would like to identify these points. To do this, we need to select just the last element of the vector, and we're just going to write port com length of port com. I'm writing length of port com on purpose, so that maybe sometimes you're not going to have the total number of time period as we had right now, and you just need to take the last element of the vector without knowing how many elements does it has. So you write it in this manner then, and then index cumulative and also length of index cumulative. Okay. So it does it like this. I put additional parentheses where it should not be, and then this one is refers to that. Okay, yeah, it closes C, and next thing we would like to do, we would like to say how many columns we want to have. Number of columns is going to be equal to number of rows. Well, I don't think it's necessary to specify number of rows here, but it's going to be 1, 2, 3 rows. Also, you would like to name actually the columns, not to refer it to the column 1 or column 2. You would like to name it so that when you print the matrix, it prints the name of the columns and the name of the rows To do it, you will do it in this in the next manner. First, you write the names, and then you need to use a list. Then you just specify the names you want to have. And to do this, you need to first specify the names for rows, and to do this you need to use again C. And here you would like first is expected return e of x. Let's call it in percents. Actually, let's make everything in percents. To do these, we can let's make a separate all this information we wrote in here. Yeah, this one C, mean, and blah blah blah. Oh no, it's okay. Excuse me. We will do it later because it's matrix. We are going to divide this performance summary by 100 to get everything in percents. So because right now it's like it can be 0.5, but we want to see it as 50%. In percents. Then next element here is going to be sigma, again in percent, and then cumulative return, again in percent. Good. Then now we need to say the names of the columns. So first when it goes portfolio, then index portfolio, then we want to see index. So our strategy, and then index, and close, and close. I believe now it shall work. Okay, this one closes that one, it closes list. This one, like that. So let's run it. Good. So actually, if you will just write it right now in here, performance summary, and press enter, say it says strategy and an index, but it's not in percents, so we need to multiply it by 100 to get the real percents. Performance summary, multiplied by 100. And then we would like it to be shown performance. So pretty much what you can write print. It's to show anything in here. Performance summary. Performance summary. So if you run it again, bam, printed. And now you see all the element is in percents. Really? Something went wrong here as well. Portfolio cumulative, but it's definitely less than 0, and here it shows more than 0. Okay. And then let's take a look at what length give us. Port 523, its ID time, wide, then okay, it messed up. So what it does, so here it is, our mean standard deviation. Okay, I see. So what it did, it took the mean in here. So okay, so then it changes a little bit. We have to rearrange the whole data. It appears that it doesn't put it like in the way I thought it will put. So I thought it will just write mean and then take. So I thought MATLAB. Oh, excuse me. I thought R is going to put it like this is the first row, this is the second one, and this is the third one. Well, it doesn't do it in this way. What it does, it fills each and every column. So this is going to be the first column, and this is going to be the second column. So to make it to correct it, you need to replace pretty much swap places of the variables. So we're going to do it right now here and also here. Now everything shall work as it should, so let's run the whole thing. Yeah, so right now we know that our expected return daily is minus, whereas index is the plus, then it's minus 53%, whereas index is 27%. Good. And we want also to show the stocks so that we know which stocks we would like to include in our portfolio according to our strategy. And let's say you need to print and you would like to some kind of say that this is a different block, so you can just use this symbol and I'm just going to copy and paste it once again, and we're going to say that this is no, it's not Sparta. If you want to make it in a fancy way, you can just write it in like that and then write stocks to invest in, something like that. So it will print it in this nice and neat manner, and then we would like to show the names of the last stocks. And actually what we can do, we have to run again loop id equal in 1 to 10. We would like to find stocks in our portfolio at the last time, and it is num time. It's pretty much instead of num time you can use length portfolio. Well, just to save space here, we're not changing it, we're going to use num time. And we would like to specify ID, so it finds the element. So pretty much what we want to do, we would like to select the element, each element of this matrix, and we would like to connect it to our stock database. So we would like to print the name of this. So this, we got the ID of the stock, and we're going to take a look at our stock data, which will have this ID. And then we would like to address to name of the stock. That's it. And also let's run it and see how it will work. Okay, this was obviously I put one more which should not be there. So if we run it, okay, error in print blah blah blah, could not find function portfolio. Oh, this is because I didn't use it in the correct way. I should not use I should not use parentheses, I should use brackets instead. And error unexpected. Okay, one more bracket missing. Yeah, because here I put 2, so here it should be 2 as well. Okay, one more time. Good. Everything works as it should. Why it shows an error here? If you go in our portfolio and you will track down, you will see that here it's zeros, and as I told you, there are no 0 column or 0 element. There is ID starts from 1. To get rid of this thing, you would like to say if this element portfolio noontime ID is more than 0, then you only want to print it. Otherwise, I wanted to print that there is no stocks found. And I don't even want you to go and check all other stocks here, because if you take a look, if it would be stock, it's so pretty much, let's say it will consider this thing. It takes a look here, then it finds 0, and obviously next all other elements is going to be 0. So there is no need to check if they are 0 or not. But our loop will check each and every cell. So how can we say it not to do it? Well, we just write one thing. We'll write break. What it does, it stops the loop. If you have double loops, like folded loops they called, so pretty much loop in loop, writing one break will break only, or will terminate the latest loop. So for example, in this case, if I will write break somewhere here, it will terminate this loop, but this loop will go on. If I want to terminate both of the loops, this and that one, I will need to write double break, like break, and I mean not double break as this, just write it 2 times, like break. Why you would like to do this? Well, imagine you have a code which tries to do some optimization maybe, or tries to find optimal some kind of value, and then you don't really need to check each and every value. You need to find the unique one, and you have some kind of way to find it. And when you got it, you don't want the code to continue to execute. So this is why you would like to use this command break. Okay, let's take a look. No stocks found. Sounds okay for me. And some of you may say, but these things are shown here. Well, it will not show if you will select the whole script. Let's say starting from here. I'm not selecting this one because it takes too much time to calculate. Well, you see this the strategy. It shows us everything, then it shows stocks to invest in, then it shows that no stocks were found. Good. Then I believe that this is it. You know how to plot. I showed it to you, and I think we did everything. And we can cross out of a 5th logical block right now. So thank you for watching this R tutorial. Congrats for watching the last 5th video. I hope that you have also watched the previous ones. And I wish you a good day and nice coding. And also would like to say that sometimes it may take some time to debug the code, but usually it's worth it. You will spend less time debugging comparing to doing everything pen and paper or doing everything in Excel. Again, thank you for watching, take care and goodbye.